All right, let's go. Number 8. The temple that broke the timeline. For most of the 20th century, the story archaeology told about the beginning of civilization was simple and orderly. First came agriculture. Farming produced surplus food. Surplus food allowed people to settle in one place instead of chasing herds across the land. Settlement produced villages. Villages produced specialization, and specialization eventually produced the leisure time and social hierarchy needed to build temples and organize religion. Religion, in other words, was a late invention, a luxury, something built on top of a full stomach. Then, in 1994, a German archaeologist named Klaus Schmidt began excavating a mound in southeastern Turkey that local farmers had been plowing around for generations, a hill they called Gobekli Tepe, the Potbelly Hill. Schmidt had actually walked past the site once before, in 1983, as part of a survey team from the University of Chicago and Istanbul University. And the team had noted the broken limestone slabs scattered on the surface and moved on, assuming they were medieval grave markers from a nearby cemetery. It took over a decade before anyone looked closer. When Schmidt's team finally excavated, what came up out of the ground did not fit the story at all. Massive, T-shaped limestone pillars, some standing over 5 meters tall and weighing upward of 10 tons, arranged in circular enclosures and carved in relief with foxes, boars, vultures, scorpions, and snakes rendered with a level of stylistic sophistication that should not have existed yet. Radiocarbon dating on organic material recovered from the enclosure fill placed construction at roughly 9600 BC, which makes Gobekli Tepe older than Stonehenge by about 6,000 years and older than the invention of pottery, writing, the wheel, and metallurgy by a comparable margin. It predates agriculture itself. There was no permanent water source at the site. There is no evidence the people who built it lived there year-round. Botanical and faunal remains recovered from the fill suggest the builders were hunter-gatherers, subsisting on wild game and wild einkorn wheat, not the domesticated crops that were supposed to come first and make a project like this possible. Schmidt's own conclusion, laid out across years of excavation reports and later summarized in his book published shortly before his death in 2014, was blunt. First came the temple, then came the city. Religion, on this reading, was not the reward for civilization. It may have been the cause of it. Mainstream archaeology has not rejected this conclusion so much as spent 30 years trying to metabolize it. Some researchers, including members of the German Archaeological Institute team that continued the excavation after Schmidt's death, have pushed back on the framing of Gobekli Tepe as a purely ritual site with no permanent population, pointing to evidence of domestic structures, grinding stones, and food storage found in later excavation seasons that suggest people may have lived there at least seasonally, which would soften the temple before city narrative without erasing it. That is a fair and evidence-based correction, not a debunking. What survives the correction is the date. Somebody with no metal tools, no draft animals, and no wheel-organized labor on a scale that required moving 10-ton stones from a quarry hundreds of meters away, and they did it 6,000 years before Egypt had a single pyramid. Hold that shape. A civilization capable of monumental stone architecture existing thousands of years earlier than the textbooks assumed is about to come up again, on a different continent, carved into a very different kind of rock. There is a further layer to Gobekli Tepe worth sitting with before moving on, because it complicates the site as much as it confirms its importance. Around 8,000 years ago, roughly 1,000 years after the last enclosures were raised, the people using the site did something almost as strange as building it in the first place. They buried it, deliberately and completely. Excavation reports describe the enclosures backfilled with a mixture of rubble, animal bone, and flint debris, packed in tightly enough that the entire complex was sealed beneath the surface of the hill until Schmidt's team began digging it out again nearly 10,000 years later. Nobody knows why. It could have been a ritual decommissioning, a closing ceremony for a sacred space that had run its course. It could have been a practical response to changing climate or population, an abandonment tidied up on the way out. What it means for us is more mundane but no less important. The deliberate burial is very likely the reason Gobekli Tepe survived at all, preserved under compacted fill for 10 millennia, instead of being weathered flat or quarried for building stone, the way most exposed monuments of comparable age eventually are. Which raises an uncomfortable statistical question that Schmidt himself raised in interviews before his death. If one site this old only survives because it happened to get buried on purpose, how many others like it were never buried and are simply gone? Number 7. The machine inside the shipwreck. In 1901, a group of Greek sponge divers, working off the small island of Antikythera, caught in a storm and forced to shelter near the coast, discovered the wreck of an ancient cargo ship lying roughly 45 meters down. Over the following months, Greek naval divers, using primitive hard-hat diving suits, recovered bronze and marble statues, jewelry, glassware, and coins from the wreck, all of which was hauled up to the National Archaeological Museum in Athens and catalogued as an unusually rich haul of Hellenistic-era shipwreck cargo, likely dated by the ceramics and coins to sometime around 60 BC. Among the recovered material was a shapeless, corroded lump of bronze and wood that sat largely ignored in the museum's storerooms for months, until it split apart on its own from the drying of the wood inside it and revealed gear teeth, small, precisely cut bronze gears, packed together inside a wooden case roughly the size of a large book. The physicist and mathematician Derek de Sola Price, working with the museum decades later, beginning in the 1950s, and using early gamma-ray and X-ray imaging techniques developed with the Greek physicist Charalampos Karakalos, spent years piecing together what the device actually was. His conclusions, published in a 1974 monograph, described a mechanism containing at least 30 interlocking bronze gears, one of them a sophisticated pin and slot gear designed to model the elliptical, non-uniform motion of the moon across the sky, a level of astronomical modeling not seen again in the surviving record for well over 1,000 years. Later work using high-resolution X-ray computed tomography, carried out in the 2000s by the Antikythera Mechanism Research Project, a collaboration including researchers from Cardiff University, pushed the reconstruction further, revealing inscriptions naming the Saros cycle used to predict eclipses, a dial tracking the 4-year cycle of the Pan-Hellenic Games, including the Olympics, and gearing that modeled the combined motion of the sun, moon, and all 5 planets visible to the naked eye. The mechanism did not just tell time. It predicted the future position of celestial bodies decades in advance, turned by a hand crank, read-off dials calibrated with a precision that assumes the user already understood planetary motion in mathematical terms, usually credited to astronomers working centuries later. No comparable device survives from antiquity. None is mentioned in surviving Greek scientific texts in enough mechanical detail to have allowed reconstruction, though ancient writers including Cicero, in a passage written around 45 BC, do describe a bronze device built by Archimedes that modeled the motions of the sun, moon, and planets, which some researchers have proposed as a possible ancestor of the Antikythera design, or even, more speculatively, as a lost twin. The mainstream explanation for why nothing like it survives is straightforward and reasonably well supported. Bronze was valuable and got melted down and reused constantly in antiquity. So the survival of any single complex bronze artifact was always going to be a matter of rare accident, a shipwreck freezing one object in time, while every workshop copy on land was eventually recycled into something else. That is a plausible account of preservation bias, not proof that other devices didn't exist. What the Antikythera mechanism actually proves, sitting under glass in Athens right now, is that someone in the 2nd century BC had already solved problems of applied astronomy and precision gearing that historians spent most of the 20th century assuming were reinvented from scratch in medieval Europe. A genuine technological peak, reached and then apparently lost, the 2005 to 2006 imaging campaign, using a bespoke computed tomography scanner built specifically for the project by the British company X-Tech Systems and shipped to Athens because the fragments were too fragile to transport, revealed something the earlier X-ray work had missed entirely. Nearly all the surviving inscriptions, thousands of characters of ancient Greek text packed into spaces smaller than a fingernail, essentially an instruction manual engraved directly onto the device itself, describing which dial showed what and how to read it. That detail matters because it tells us this was not a one-off curiosity built by a single eccentric genius and never repeated. An object built to be explained to its user, with a user's manual etched into the casing, is an object that assumes an audience who might not already know how to operate it, which is exactly what you would expect from a market, however small, of buyers who were not the engineer who designed it. A 2008 paper by the Antikythera Mechanism research project team went further, identifying the Corinthian month names inscribed on one of the dials, which narrowed the mechanism's likely origin to a Corinthian colony, with Syracuse in Sicily, the city where Archimedes lived and died, as the leading candidate. If that identification holds, the device recovered from a shipwreck 2,000 years later may be a direct descendant, built in the same city, of the very bronze sphere Cicero described. If you're the kind of person who wants the discoveries that complicate the textbook version of history rather than the sanitized one, go ahead and subscribe now, because this list is about to get considerably stranger. Number 6. The caverns nobody claimed. In June of 1992, a farmer in Longyu County, in China's Zhejiang province, decided to pump the water out of a series of ponds on his land that local tradition called the bottomless ponds. Ponds nobody in living memory had ever tried to drain. What emerged, after weeks of pumping, was not a natural sinkhole, but the ceiling of an enormous man-made cavern, hollowed directly out of solid siltstone bedrock. Further draining and excavation eventually revealed 24 separate caverns spread across roughly 1 square kilometer, some with ceilings rising more than 30 meters above the floor, their walls and ceilings covered edge to edge with parallel chisel marks, spaced with an almost mechanical regularity, roughly the width of a human hand apart, running in continuous unbroken lines across surfaces the size of a house. Each cavern was carved with load-bearing stone pillars left in place to support the ceiling, precisely positioned and evenly spaced. The work of engineers who understood structural stress well enough to hollow out a mountain from the inside without collapsing it. And here is the detail that makes this entry different from almost everything else on this list. There is no surviving record of who built them, when or why, no inscriptions naming dynasty, no local legend older than a generation or two, no mention in any of China's extraordinarily thorough dynastic historical records, which is itself remarkable, given how meticulously Chinese court historians documented public works projects going back thousands of years. Archaeologists and geologists who have studied the site, including teams that presented findings at international academic conferences convened at the site in the years following its discovery, generally date the caverns to sometime within the last 2,000 years based on toolmark analysis and comparison with regional quarrying techniques, with many favoring the Ming Dynasty or earlier periods as the likely construction window. And most propose the caverns were quarried to extract stone for regional building projects, with the elaborate finish work explained as evidence of skilled specialist labor rather than anything stranger. That is a reasonable, evidence-grounded theory, and it may well be correct. What it does not explain is the silence. A project on this scale, requiring the removal of an estimated hundreds of thousands of cubic meters of stone by hand, using tools that left no trace of iron residue in the tool marks, according to several material analyses conducted on site, organized labor at a scale comparable to building a mid-sized pyramid, and yet it left no trace in the written record of a civilization that wrote almost everything down. Compare that to Gobekli Tepe from a few minutes ago, a monument built before writing existed to record it. The Longyu Caves are the opposite problem. A monument built inside a civilization that had writing, and record-keeping, and bureaucracy obsessed with documentation, and somehow it slipped through anyway. Visitors who have walked the drained caverns since they were opened to the public in the 1990s describe a further detail that photographs struggle to convey. The chisel work is not just regular, it is uniform across the entire complex, as if every one of the 24 caverns, some of them not connected to each other by any known passage at the time of excavation, was cut according to a single shared design standard, maintained by whoever was directing the labor from cavern to cavern, over what would have had to be years, possibly generations, of continuous work. That level of standardization across a project this size is itself a form of evidence. It implies not a scattered, informal quarrying operation, but something closer to an organized state or institutional undertaking, with a chain of command precise enough to keep the tool mark spacing consistent across a square kilometer of excavated stone. And yet, whatever institution ran it left no name behind. Regional gazetteers from the Ming and Qing dynasties, the kind of local administrative records that routinely note bridge repairs and temple construction, are silent on the caves entirely, and the pond folklore that eventually grew up around the site, warning that the water was bottomless and cursed, reads less like a memory of who built the caverns, and more like an explanation invented later by people who had genuinely forgotten. Number 5. The jar that might have made lightning. In 1938, the Austrian archaeologist Wilhelm Koenig, working as director of the National Museum of Iraq, was cataloging objects recovered years earlier from a site near Kujut Rabu, close to Baghdad, when he examined a small clay jar, roughly 13 centimeters tall, dated by the surrounding archaeological layer to the Parthian period, sometime between 250 BC and 250 AD. Though some later researchers have argued for an earlier Sassanid-era date based on comparable pottery styles. Inside the jar was a copper cylinder, closed at the bottom with a copper disc, and inside the copper cylinder sat an iron rod, corroded and pitted in a pattern Koenig recognized from his prior work, Restoring Ancient Artifacts, a pattern that in his professional experience typically resulted from acidic electrolytic corrosion. Koenig published a paper in 1940 proposing that the object was, in effect, a primitive galvanic cell, an ancient battery, and that if filled with an acidic liquid such as vinegar or wine, the copper and iron components would generate a small but measurable electric current. The theory found an unlikely champion after the war in Willard Gray, a General Electric engineer, who in the late 1940s built a working replica, filled it with grape juice, and reportedly measured around half a volt of current, later reproduced by other researchers, including the German Egyptologist Arne Eggebrecht, in the 1970s using a similar acidic solution and reporting comparable readings. Half a volt is not much. It would not power a light bulb. Proponents of the battery theory have suggested a plausible, if unproven use: electroplating, running a weak current through a solution to deposit a thin layer of gold or silver onto a base metal object. A technique that would explain the gold-gilded silver artifacts found elsewhere in the region from a similar period, without requiring the far more labor-intensive fire gilding process normally assumed. It is a genuinely elegant explanation. It is also almost certainly wrong, or at least unproven, and the reasons why are worth taking seriously, rather than skipping past. No wiring has ever been found connecting a Baghdad battery to anything. No ancient text from Mesopotamia, Persia, or the wider region describes electricity, electroplating, or any application that would require this kind of device in a region and period with a substantial surviving body of technical and religious writing that mentions no such thing. Several archaeologists, including Marjorie Seneschal of Smith College, later pointed out that the object's construction is consistent with a far more mundane and well-documented use: a container for storing sacred scrolls, with the corrosion pattern on the iron rod explainable by ordinary chemical reaction, with damp organic material sealed inside a jar for 2,000 years, no battery required. Both readings remain on the table because the honest answer is that nobody knows for certain, and an object without an accompanying written explanation from the people who made it will always support more than one interpretation. What is not in dispute is that the object works as a low-voltage electrochemical cell when you fill it with an acid, whether or not that is what it was originally built to do. There is a further wrinkle that rarely makes it into the popular retellings. The Baghdad object was not unique. Similar jars containing similar copper cylinders and iron rods were later identified among artifacts recovered from Seleucia, another site in the same general region, meaning whatever this object was, it was manufactured more than once by more than one workshop, which cuts somewhat against the idea of a single freak curiosity and toward the idea of a repeated, intentional design, however mundane its actual purpose turns out to have been. The original jar itself, along with a substantial portion of the National Museum of Iraq's collection, was reported looted during the chaos that followed the 2003 invasion of Iraq. and its current whereabouts, along with the possibility of any further direct testing, have remained uncertain in the years since, which means the object at the center of one of the 20th century's most argued over archaeological questions is not currently available for anyone to re-examine. Number 4. The map that shouldn't exist. In 1929, during a survey of the Topkapi Palace Library in Istanbul, commissioned by the Turkish Ministry of Education, a German theologian named Gustav Adolf Deismann came across a gazelle-skin parchment map, painted and signed in 1513 by an Ottoman admiral and cartographer named Piri Reis, a nephew of the famous Ottoman corsair Kemal Reis. The map itself is a fragment showing the western coast of Africa, the eastern coast of South America, and a southern coastline that continues below the point where South America should end. Piri Reis included marginal notes on the map describing his source material, and this is the part that matters. He explicitly states he compiled the map from roughly 20 older charts, including several captured or acquired Portuguese and Spanish source maps, and one that he says was used by Christopher Columbus himself, a claim that cannot be independently verified, but which fits the documented pattern of Ottoman naval intelligence, actively collecting captured European nautical charts during this period. The controversy centers on that southern coastline. In 1956, a U.S. Air Force officer named Harold Ohlmeyer wrote to the American writer and self-described diffusionist researcher Charles Hapgood, agreeing with Hapgood's proposal that the coastline depicted on the map's lower portion resembled the coast of Antarctica's Queen Maud Land, a landmass that would not be discovered under its ice sheet by modern seismic surveying until the mid-20th century, roughly 400 years after Piri Reis drew his map. Hapgood expanded this into a broader 1966 book arguing that the map preserved knowledge from a lost, technologically advanced civilization that had mapped Antarctica before it was covered in ice, a claim later amplified considerably in popular nonfiction accounts throughout the 1970s and 90s. Mainstream cartographic historians reject the Antarctica identification specifically, and their argument is worth actually engaging with rather than dismissing outright. Gregory McIntosh, a historian of cartography who published a detailed 2000 study of the Piri Reis Map, argues the southern coastline is not Antarctica at all, but rather a somewhat distorted, speculative continuation of the South American coast, curved eastward to fit the available parchment space, consistent with a documented and common cartographic practice of the period where mapmakers extended known coastlines with guesswork to fill the page, sometimes bending them to match classical geographic theory about a hypothetical southern landmass balancing the globe. That is a specific, testable, well-reasoned objection, grounded in comparison with other contemporary maps that make the same kind of speculative extension. It has never fully settled the argument because the coastline's specific bends have continued to generate disagreement among cartographic historians about exactly how good or bad the resemblance to Queen Maud Land actually is. What is not disputed by either side is the map's core, verifiable claim. A 16th century Ottoman admiral was working from a library of source charts, several of them now lost, that recorded exploration voyages and geographic knowledge no surviving European archive from that period fully preserves. Piri Reis was not a fringe figure making unverifiable claims from nowhere. He was a serving Ottoman naval officer who went on to author the Kitab-i-Bariyai, a detailed navigational treatise covering the coastlines and harbors of the Mediterranean.
Right.
And he was eventually appointed admiral of the Ottoman fleet in the Indian Ocean, a career that ended when he was executed in 1553 by order of the Ottoman authorities after a failed campaign, a detail that at minimum confirms his access to serious state-level naval intelligence rather than folk rumor. Only about one-third of his original 1513 map survives. The rest was lost or destroyed at some point in the intervening 4 centuries, meaning whatever the missing two-thirds showed, including potentially additional coastline that might have clarified the entire Antarctica argument one way or the other, is very likely gone for good. The debate, in other words, is being conducted over a fragment of a fragment, source charts that no longer exist, condensed into a map that itself is only partially intact. Number 3, the boundary layer that ends in age, roughly 12,900 years ago, At a point in the geological record known as the onset of the Younger Dryas, the climate of the northern hemisphere underwent an abrupt reversal. After thousands of years of gradual post-ice age warming, temperatures plunged back toward glacial conditions in what ice core records from Greenland show was an astonishingly fast transition, some estimates placing the core temperature shift within a matter of decades rather than centuries. Roughly 35 genera of North American megafauna, including mammoths, mastodons, saber-toothed cats, and giant ground sloths, disappeared from the fossil record at approximately the same window, alongside the disappearance of the Clovis culture, the tool-making tradition associated with some of the earliest well-documented human populations in the Americas. For decades, the leading explanations were gradual climate shift and human overhunting, and both remain part of the mainstream picture today. In 2007, a team of researchers led by geophysicist Richard Firestone published a paper proposing a third, more dramatic mechanism, that a fragmented comet or asteroid, breaking apart and impacting or airbursting over the North American ice sheet, triggered the sudden cooling directly, both by injecting dust and debris into the atmosphere and by destabilizing the ice sheet itself. Their evidence centered on a thin sediment layer found at multiple sites across North America, and later argued to extend into Europe and the Middle East, a layer containing elevated concentrations of nanodiamonds, melted glass spherules, and unusually high platinum concentrations, all of which are associated with cosmic impact events elsewhere in the geological record, sitting directly at the Younger Dryas boundary and capping a dark, carbon-rich sediment layer nicknamed the Black Mat by researchers, above which the megafauna fossils abruptly stop appearing. The hypothesis has faced substantial and serious pushback from within mainstream geology. Multiple follow-up studies, including a widely cited 2011 paper by a team led by Nicholas Pinter, failed to replicate the nanodiamond and platinum concentrations at several of the original sites, and questioned whether the identified particles were genuinely impact-related rather than the product of ordinary wildfire activity or contamination during sample handling, and no confirmed impact crater of the necessary size and age has ever been located, which for a hypothesis this dramatic is a significant unresolved gap. That is a legitimate and unresolved scientific dispute, not a settled debunking, and the argument has continued for over 15 years, with researchers on both sides publishing competing data as recently as the 2020s, including newer platinum anomaly findings from Greenland ice cores and South African sites that impact proponents argue support the original hypothesis. Here is why this entry belongs on this list, rather than in a separate video about climate science. Gobekli Tepe, the temple from the top of this list, was built within roughly 1,000 years of this exact boundary event, by a hunter-gatherer population living through the tail end of precisely the climatic chaos this hypothesis describes. Some proponents of the impact hypothesis, including the writer Graham Hancock, have pointed to a specific carved pillar at Gobekli Tepe, known to researchers as the Vulture Stone, which depicts a scorpion, a headless human figure, and what has been read by some as an arrangement of animal symbols potentially corresponding to constellations, as a possible symbolic record of the catastrophe. That specific interpretation is speculative and rejected by the archaeologists who actually excavated the site, who read the imagery as conventional funerary and totemic symbolism consistent with other Neolithic sites in the region. But the underlying timeline is not speculative. A society was rebuilding itself monumentally in stone in the exact aftermath of the most violent climate whiplash the Holocene record shows. The scale of the cooling itself is worth stating plainly, because it is easy to undersell in passing. Ice core data from Greenland, cross-checked against lake sediment records in Europe, indicate temperatures across parts of the northern hemisphere dropped by somewhere between 4 and 8 degrees Celsius, with some regional records suggesting the sharpest part of the transition occurred within as little as 1 to 3 decades, a shift that would be genuinely catastrophic if it happened in a single human lifetime today, let alone to hunter-gatherer populations with no stored surplus and no infrastructure to buffer a sudden multi-year collapse in the availability of game and edible plants. Whatever caused it, gradual orbital forcing, a sudden pulse of glacial meltwater disrupting Atlantic Ocean circulation, which remains a leading and well-supported explanation, independent of any impact hypothesis, or a comet fragmenting over the ice sheet. The population living through it did not have the luxury of knowing which explanation was correct. They only had the collapse itself and what they built afterward. Whether or not the Vulture Stone is a calendar of catastrophe, Gobekli Tepe stands as physical proof that at least one Neolithic population responded to the hardest reset the climate record shows in the last 100,000 years by building something monumental rather than simply surviving it. Number 2. The fingerbone that rewrote the family tree. In 2008, in a cave in the Altai Mountains of southern Siberia called Denisova Cave, a site that had been excavated intermittently since the 1970s, Russian archaeologists recovered a small fragment of a fingerbone from a young girl, found in a sediment layer roughly 40,000 years old. The fragment was unremarkable to look at, one of thousands of small bone fragments recovered from the site over decades. It was sent to the Max Planck Institute for Evolutionary Anthropology in Leipzig, where a team led by the geneticist Svante Pabo sequenced its mitochondrial DNA in 2010, expecting to confirm it as either an early modern human or a Neanderthal, the two hominin populations already known to have occupied the region. The genetic sequence matched neither. It represented an entirely unknown branch of the human family tree, a population now called the Denisovans, known to this day almost entirely from genetic material rather than from a substantial skeletal record, since the total physical remains ever recovered amount to little more than a finger bone, a few teeth, and a handful of additional bone fragments, one of them identified only in 2019. What makes this discovery genuinely destabilizing to the field is not just that a new hominin species existed, but what the genetic data revealed about contact. Comparative genome analysis, published by Pabo's team and subsequent researchers throughout the 2010s, showed that Denisovans interbred with both Neanderthals and early modern humans, leaving a genetic signature that persists today at meaningful levels, up to roughly 4 to 6% of the genome, in modern populations across Melanesia, Australia, and parts of Southeast Asia, with smaller but detectable traces found across East and South Asia. A 2014 study led by geneticist Rasmus Nielsen further found that a specific Denisovan-derived gene variant, EPAS1, is strongly associated with the ability of modern Tibetan populations to thrive at extreme high altitude, meaning a piece of Denisovan biology, inherited through interbreeding tens of thousands of years ago, is actively helping people survive today in one of the most oxygen-poor environments on the planet. None of this was proposed, predicted, or suspected before the 2010 genetic sequencing. The entire population, an interbreeding, geographically widespread branch of humanity that contributed working genes to living people, was invisible to the archaeological and fossil record until a single fingerbone happened to survive in a cold, dry Siberian cave, and happened to get sequenced by a lab capable of extracting ancient DNA from a fragment that's small. The obvious and uncomfortable implication, one that working paleoanthropologists have been open about in the years since, is that the fossil record almost certainly preserves only a fraction of the hominin populations that once existed, and that the human family tree as currently drawn is very likely missing branches nobody has found the bone to prove yet. The Denisovans get stranger still once you look at the timeline of the identifications themselves. For years after the 2010 genome was published, researchers had genetic proof that this population existed and had contributed meaningfully to living human DNA, while possessing almost no physical description of what a Denisovan actually looked like because the skeletal material was so fragmentary. That changed only in 2019, when researchers led by Jean-Jacques Hublin and Fahu Chen identified a large, robust jawbone recovered decades earlier from Baishia Karst Cave on the Tibetan Plateau, a site more than 2,000 kilometers from Denisova Cave, as Denisovan, not through DNA at all, since none had survived in the bone, but through ancient protein analysis extracted from a single molar, a technique called paleoproteomics that was barely mature enough to attempt the identification at the time. That single jawbone did two things simultaneously. It gave the species its first substantial piece of skeletal anatomy and it placed a Denisovan population at high altitude in the exact region later shown to carry the EPAS1 altitude gene, tying the genetic evidence and the physical evidence together 14 years after the population was first discovered, and 9 years after its genome was already being read by geneticists who had never seen its face. Number 1. Pattern underneath the discoveries. Line these 7 up end to end, and something becomes hard to unsee. A stone monument older than agriculture itself, built by people the textbooks assumed weren't capable of it yet. A bronze machine calculating planetary motion with a mathematical precision not matched again for over a millennium. A mountain hollowed from the inside with a precision that left no written trace in a civilization obsessed with written records. A jar that behaves like a battery, whether or not anyone can prove it was built to be one. A map preserving source charts that no longer exist anywhere else, drawn by a culture actively collecting the intelligence of its rivals. A boundary in the ice and the sediment marking the most violent climate reversal of the modern geological age, sitting directly beneath a temple built by people who lived through it. A single finger bone, erasing the assumption that we already knew every branch of our own family tree. The individual explanations offered for each of these, and they are offered honestly, by working scientists doing careful, unglamorous, methodologically rigorous work, are not conspiracies. Preservation bias explains why so few bronze machines survive. Documentation gaps explain why a Chinese quarrying project might go unrecorded. Chemical corrosion explains the Baghdad jar without requiring anyone to have understood electricity. Cartographic convention explains a curved coastline drawn to fill empty parchment. Each explanation taken on its own is reasonable, and in several cases it is very likely correct, but taken together, a second, quieter pattern sits underneath all of them, and it isn't a pattern about ancient technology or lost civilizations at all. It's a pattern about how slowly the story gets corrected once it's been told. Every single entry on this list forced a real, working, credentialed scientific community to revise a settled assumption only after physical evidence made the old assumption impossible to hold on to. After a farmer drained a pond, after a jar cracked open in a museum basement, after a lab in Leipzig sequenced a bone fragment nobody expected to matter. None of these discoveries were predicted in advance by the models experts were using. Every one of them arrived as a surprise, forced the field to update, and in every single case, the update took years, sometimes decades, to work its way from the excavation report into the textbook, fought at every stage, not by some shadowy authority trying to hide the truth, but by the perfectly ordinary, perfectly human resistance every field of knowledge has toward throwing out a model that took a career to build. That resistance is not a cover-up. It's closer to inertia, the same inertia that makes any large, careful institution slow to change its mind, for good reasons, as often as bad ones. But inertia and suppression can look identical from the outside, and the discoveries in this list are the proof that the story is not finished, that the fossil record, the archaeological record, and the written record we have right now are not the whole picture, only the surviving fraction of it, pulled up one pond, one shipwreck, one finger bone at a time by people patient enough to keep digging in places the textbook already claimed were fully explained. If you want to see more discoveries like the ones on this list, click the video on screen now and make sure to subscribe.